Welcome back, everyone. I hope you did well on the exam. By the end of these 4 explanation videos, I promise you will find yourself more knowledgeable, understanding, and confident when tackling any mobile app testing exam. Before we dive into today's content, if you haven't already, please give this video a like and make sure you subscribe to the channel. Your support really helps us continue creating valuable content for you. In this video, we're going to discuss the answers to questions 1 through 10. It's important to carefully analyze each question and its explanation to ensure you fully understand the reasoning behind the correct answers. This can make a huge difference in your overall exam readiness. You better be ready because I'm super excited. So, let's begin with the first question. How can mobile analytics data support SDLC when developing a mobile application that uses an HR sensor to measure the user's heart rate? And the available options to choose from are A. Help understand how this sensor works and how the measured data are interpreted. B. Enable users to achieve better health by monitoring their heart rate and alert them when abnormal measures are detected. C. Aid in the process of test device selection by identifying devices that have this sensor on board. D. Support choosing the best programming language to code the application according to these analytics. Select one option. All right, so a very straightforward question here, and let's analyze each option to see which of these options represent a benefit of mobile analytics data that can support the software development lifecycle. For option A, understand how the sensor works. This one is probably not correct. Ask yourself, what has the mobile analytics data to do with understanding how the heart rate sensor works? Nothing. In fact, mobile device documentation is where we can get information about how this sensor would work and how to read the information generated from it. Now let's move to option B, which is instantly recognized as an incorrect option. This is a benefit from the mobile application itself, not the mobile analytics data. So, option B is also not correct. Moving to option C, aid in the process of test device selection. This one looks like a very solid benefit of mobile analytics data. Using mobile analytics data can help us identify which mobile devices have this heart rate sensor and also can identify which of them are mostly used within the target market. This way, we can make good decisions regarding the test device portfolio that would achieve the best coverage and also help us validate the usability of our application. So option C is a very good contender to be considered as the correct option for this question. Lastly, option D, selecting the appropriate programming language, is definitely not the correct answer, as selecting the programming language that will be used in the development process is directly related to the requirements of the project or the client. So I think option C is the only option that shows a real benefit of mobile analytics data related to the SDLC. Now, let's shift our focus to the second question, which says, you as a software tester are requested to test a mobile application with the following criteria. 1. The app is free to download. 2. The app is free to use for the most part. 3. The app requires the user to pay for certain features. Which of the following options represents the mobile business model this app probably follows? And the available options to choose from are A. Enterprise model. B. Free model. C. Fee-based model. D. Freemium model. All right. So this question challenges our understanding of the mobile business models. Let's see what are the characteristics of this mobile app. First, the app is free to download. Thus, we can exclude option C, which claims that this is a fee-based app. Second, the app is free to use for some parts but requires paying a fee for some features. This sounds very much like a freemium model. So, I can safely assume that option D is probably the correct answer to this question. However, let's take a look at the remaining options. Options A and B. Option A, enterprise model. This is probably not correct, as there's nothing in the question stating that the app is exclusively used internally by an organization's employees. And option B is also not true, as this is obviously not a free model because users may have to pay some fees at some point. This confirms that the answer to this question is definitely option D. Now is the time to answer question number 3, which says, which of the following statements is true when it comes to basic phones? A. They have limited internet connectivity. B. They cannot make calls if no SIM card is installed. C. They do not have any games installed on them. D. They support simple low-resolution cameras. So this one is a very simple and straightforward question, and an easy one too. So let's verify each statement and see whether it applies to basic phones or not. Option A is of course not true, as basic phones do not have any internet connection capabilities altogether. This option actually resembles feature phones. So option A is out. Next, option B claims that basic phones will not be able to make calls if no SIM cards are installed in them, which is very true if you think about it. Basic phones do not have any internet connectivity, so no Wi-Fi calling is possible for this type of phone. The only way for basic phones to make calls is by using GSM networks. And since they definitely do not support eSIMs, a physical SIM is a must for them to be able to make calls. So we will put option B in mind as a strong contender to be the correct answer to this question. For option C, it seems incorrect, as I remember playing the all-famous Snake game on my Nokia 3310 a long time ago. In case you do not remember, basic phones come with some apps and games pre-installed, but they do not support installing external ones. Lastly, option D is also instantly recognized as an incorrect option. Basic phones do not support cameras, and these low-resolution ones are sometimes found in feature phones. Cool. Now we can confirm that option B is very much the correct answer to this question. Things are going well, so let's quickly encounter question number 4. Your team is developing a small-size website that serves the function of sending notifications to users when there's a storm coming in the next 48 hours in their area. Knowing that the development budget is not that huge, what would be the best application type suitable for such an application? A. Native app. B. Web-based app. C. Hybrid app. D. None of the above. So, this question describes a case where a small budget is available to develop a small-sized mobile app. However, the issue is that we would need to use some of the device features and sensors. For instance, the notification feature is important in order to alert the users when there's a storm on the way. Plus, the GPS sensor will be used to determine the location of the user and tell them if this location is safe or not. This means that a web-based application might not be a viable option in our case, as these web-based apps do not have full access to all device features and sensors. So we're left with one of these two options: native apps or hybrid apps. For native apps, they could be a fantastic option, but because of the high budget and effort required to develop such apps, they might not be the best option for our case. Now, because hybrid apps use a common web technology, they are easy to develop, won't cost as much as native apps, and can access device features and sensors. But what about the drawbacks of hybrid apps, such as probable performance issues? Well, the app we want to develop is relatively simple and does not require a ton of resources. So, we can get away with some performance limitations in favor of cheaper development and testing costs. Taking all of these factors into consideration, it makes a lot of sense to build this application as a hybrid app. This type is the perfect candidate for this project. So option C is the best answer to this question. Next, let's take a look at the 5th question in this series, which says, you're testing a mobile app with the following characteristics. 1. Continuous data synchronization. 2. Always connected. 3. Fat client. Which of the following represents an app that has no option but to adhere to these characteristics? A. Video calling app. B. Advanced scientific calculator. C. Web version of a Forex trading platform. D. Video editor app. Very nice. So, what we need to do here is figure out the app that has no other choice but to have all these three characteristics at once. The app we pick must use continuous data synchronization, always connected mode, and should be a fat client. Let's now take a look at these four options and analyze them. Starting with the first one, a video calling app. I can say that this app must use continuous data synchronization mode, as this is super important to allow for instant communication between the two sides of the video call. Also, it makes sense that this app must be an always connected app, as the core functionality of this app necessitates internet connectivity. And lastly, being a fat client is a must, since the app has to use a lot of the device sensors and features, such as the camera and microphone. So, this option is a very strong contender to be the correct answer. Moving to the second app we have on our list, the Advanced Scientific Calculator. This one is a big no. What would a calculator app need to be always connected for? There's no rationale for that, of course. Hence, we can exclude option B from the possible answers to this question. Now onto the third option, the web version of a Forex trading platform. This one is also not a viable option, as we all know that web-based applications are thin clients, not fat ones. So, this is also not the answer we're looking for. And lastly, option D, the video editor app. I can also say no to this. Deciding that your app is going to be an always connected app is something you should be careful with. People do not have 24/7 internet connections, and many users won't understand why a video editing app would need a persistent internet connection. Maybe the app would require an internet connection to download some assets, such as effects or templates. But the main functionality of the app, which is video editing, should be available even without an internet connection. So, a video editing app is better suited as a partially connected app rather than an always connected one. Analyzing our findings so far, I believe option A, the video calling app, is the best matching option to our understanding of the question's context. All right, now let's shift our focus to question number 6, which says, you received a user report that your app crashes on iPhone 6s version 13.0 when the user turns off Wi-Fi while the app is in the foreground. You tried to buy the same phone, but it's no longer in stock. Which of the following choices resembles the best option you should utilize? A. Remote device access service. B. Simulators or emulators. C. Crowd testing services. D. Test on a newer iPhone. Very well. So, our app received feedback from a user using quite an old phone, the iPhone 6s, with an unupdated version of iOS 13.0. Now, the first thing to do in order to fix this issue is to replicate the failure by repeating the steps that led to the issue. Let's analyze the options. Option A suggests using a remote device access service, which is a reasonable choice. By using one of these services, we can log into a platform, select a phone that matches the user's device, in this case, an iPhone 6s with iOS 13.0, and perform the necessary testing. This method is efficient and cost-effective, especially since we only need to test a single device for a short time. So let's keep option A as a strong contender. Option B recommends simulators or emulators. This could be a good option, but not the best one. While we can simulate an iPhone 6s with iOS 13.0, the problem described involves hardware elements like the Wi-Fi controller, which simulators and emulators may not accurately replicate. This limits our ability to reproduce the issue. So option B is not ideal. Option C suggests crowd testing services. This is a more expensive option and doesn't seem justified for this specific issue. With only one user report on a single device, using crowd testing wouldn't be cost-effective or necessary. So, option C is not appealing. Finally, option D proposes testing on a newer iPhone. This is a poor choice because a newer iPhone will likely have a different iOS version, hardware, and Wi-Fi controller, making it difficult to reproduce the exact issue. So, option D is not a good approach either. Therefore, it's clear that option A, using a remote device access service, is the best option. It allows us to investigate the issue in a cost-effective way while ensuring we have the right device set up to replicate the problem. Moving to the next question, question number 7, which says, when it comes to mobile application testing, which of the following statements represents the best option to tackle the diverse groups of people that might use our app? A. Unit testing. B. Security testing. C. Component integration testing. D. Beta testing. Select one option. Very nice. So as we all know, mobile app development and testing has some additional challenges if compared to something like desktop apps. One of these challenges is the different user groups that might use our mobile app. Different user groups means different perspectives, needs, and expectations, which our app must fulfill. Now, we're required to pick the option that best resembles how we can overcome this challenge. Let's analyze these options. Looking at option A, we can immediately recognize that it's not the answer we're looking for. Unit testing is performed at very early stages of the software development lifecycle to ensure bulletproof code and is not related directly to fulfilling the end user's needs. Moving to option B, security testing. Also, not a very good option here. Yes, security is something awesome to have in a mobile application, but what has security testing to do with fulfilling the usability, look and feel, and smoothness of the app? So, again, not the answer we're looking for. Now, option C is very similar to option A, as component integration testing is also conducted at very early stages of the SDLC and is not directly related to fulfilling the end user needs. Lastly, we reach option D, which should be the correct answer. And yes, it is. Beta testing is one of the forms of acceptance testing, in which a group of real users can try and test the app and then provide feedback about the application. Users can share what they liked, what they didn't like, and what they feel needs improvement. The feedback is then collected and discussed by the development and testing teams, and changes are applied accordingly to the app to make it more user-friendly. Excellent. We can now confirm that option D is the best option for this question. All right, let's quickly move on to question number 8. Your manager asked you to prepare an updated list of the most used devices in the market. Which of the following risks is the one your manager is probably considering at the moment? A. The risk of high feedback visibility of the mobile apps. B. Different tools to be used in testing the app. C. Different networks the app will connect to. D. Different OS versions the app will work on. Now, this is an interesting scenario. Our manager is considering a risk related to mobile app testing. And to mitigate this risk, he requested us to do a research about the most used mobile devices in the market. This question challenges us to get into the manager's brain and identify the risk he is focusing on. Okay, fair enough. Let's start by evaluating option A, the risk of high feedback visibility of mobile apps. This one is indeed an important issue to handle. However, mitigating this risk involves strategies like beta testing and monitoring app reviews, and is not necessarily related to knowing the most used devices. So we can exclude option A from the list of possible answers. Next, option B talks about different tools to be used in testing the mobile application. Again, this risk can be mitigated by providing training to the test team on various tools such as simulators and emulators. Plus, maintaining clear documentation about the best practices of the test process to follow when conducting mobile app testing. This means that market analytics data about device usage doesn't help much here, and this makes option B also not a viable option. Moving on to option C, which mentions different networks the app will connect to. I believe network connectivity issues are crucial to consider, but they are usually handled by setting up private networks or performing field testing. Market data about the most used devices doesn't play a significant role in mitigating this risk. Hence, option C is not the correct answer. Finally, option D addresses the different OS versions the app will work on. This risk can be effectively mitigated by using market analytics data to identify the most common OS versions. Performing our tests on these common versions ensures broader compatibility and reduces the risk of the app not functioning well on popular devices. So option D is indeed the best option we have. All right, let's shift our focus to question number 9. Market data analytics shows that your distance measuring app is being used exclusively by iPhones. Your app uses the LiDAR sensor, camera, and GPS to accurately measure the distance between the phone and any object. Which of the following statements represents the best option when choosing the best test device portfolio? A. To reduce cost, pick one of the most used iPhone models containing LiDAR, camera, and GPS sensors. B. Use any random iPhones as long as they contain LiDAR, camera, and GPS sensors. C. Picking the most used devices while considering devices with and without LiDAR sensors. D. Testing only with iPhones is not enough. An Android phone must be added to the test device portfolio. Very nice. So, our app, which is a distance measuring app, is mostly used by iPhone users. Maybe because Apple fans always need to know exactly how far away they are from switching to the next iPhone. Anyways, knowing that our app uses LiDAR, camera, and GPS, we need to pick the option that represents the best approach for selecting test devices for this app. Let's analyze each option. Option A suggests picking one of the most used iPhone models containing LiDAR, camera, and GPS sensors to reduce costs. While this approach might seem cost-effective, it's not sufficient. If all users were using the same iPhone model, this could work, but that's unlikely. The user base probably has a variety of iPhone models, so focusing on only one model won't cover the full user base. Consequently, some users might experience issues that go untested, leading to a bad user experience for them. Therefore, option A is not the best choice in my opinion. Next, option B assumes that using any random iPhones would be sufficient as long as they contain LiDAR, camera, and GPS sensors. This approach is flawed because randomly selecting devices might result in choosing iPhone models not currently used by our user base. This would mean the app's performance and user experience for the current users wouldn't be accurately evaluated. So option B is not a good strategy. Moving on to option C, which suggests picking the most used devices while considering devices with and without LiDAR sensors. This approach is more comprehensive and takes into account the diversity of devices used by the user base. By using market data analytics to choose the most common iPhone models and ensuring that both LiDAR-equipped and non-LiDAR devices are included, we can evaluate the app's response when no LiDAR sensor is detected and test the distance accuracy with and without the LiDAR sensor. This ensures a thorough assessment of the app's functionality across a representative range of devices. Hence, option C is a very good option to keep in mind. Finally, option D suggests that testing only with iPhones is not enough and that an Android phone must be added to the test device portfolio. I feel this is unnecessary because market data shows that the app is exclusively used by iPhones. Adding an Android device to the test portfolio would be a waste of time, effort, and money, as it wouldn't be relevant to the user base. Therefore, option D is not the correct approach. So, in conclusion, the best option is option C, picking the most used devices while considering devices with and without LiDAR sensors. All right, we've made it to the final question for this video. Question number 10. In the next video, we'll be tackling questions 11 through 20, so make sure to stick around for that. And hey, if you're eager to practice more and really nail the CTMAT exam, I remind you that we've got you covered with a full 6-exam course on Udemy, which you can easily find through the link in the description. Now, let's jump into question 10 and see what we've got. You are assigned to test the performance throttling of a resource-intensive video editing app known for causing device overheating. Which of the following devices is least likely to be included in your test lab? A mobile device with a large screen, such as foldable phones. B, a mobile device with a large battery and 80-watt charging capabilities. C, a mobile device with 2 SIM cards and 5G connectivity. D, a tablet with multitasking capabilities that can run multiple apps in the foreground. All right, let's make sure we're all on the same page before we dive into analyzing the options. The context here is that you've been assigned to test the performance of a video editing app that's known to push devices to their limits. It's resource-intensive, meaning it uses a lot of processing power, memory, and possibly even GPU resources, which can cause devices to overheat. Your task is to test how this app performs under stress and monitor if or when the device's performance is throttled due to overheating. Performance throttling happens when a device reduces its speed or functionality to prevent overheating. This is a key concern when dealing with high-demand apps like video editors, especially when run on mobile devices. Now that we understand the situation, we'll go through the options and figure out which device doesn't quite fit the scenario. Starting with option A, which describes a mobile device that has a large-sized screen, such as a foldable phone. While foldable phones have larger screens that could, theoretically, generate more heat, the large surface area of the screen itself actually helps dissipate that heat more effectively. Plus, screens themselves don't typically produce that much heat anyway. Surely, there's nothing particularly unique about foldable phones or phones with large screen sizes that would exacerbate the overheating caused by our resource-hungry app. So, this makes option A the least important device to include in our test lab, and maybe we should keep it in mind as a very good candidate to be the correct answer to this question. Next, we have option B, which mentions a mobile device with a huge battery capacity and 80-watt charging capabilities. A device with a massive battery will take a longer time to recharge. This would produce heat for a longer period of time. Additionally, having 80-watt charging on board means super fast charging, which also generates a lot of heat. So imagine a user charging this phone while using our app, which already heats up the device. This situation must be tested to ensure our app can handle the additional heat from fast charging. Thus, option B is essential to include in our test lab and not the one we're looking for. Moving on to option C, which describes a mobile device with 2 SIM cards and 5G network capabilities. As a starter, having 2 SIM cards means the device can connect to 2 separate networks, which generates extra heat from the internal antennas. Add 5G capabilities to that, which are known to heat up devices even more, and you can easily make this device reach super high temperatures. This necessitates testing performance for such a device. Hence, option C is important to test. Moving to the last option, option D, which talks about a tablet with multitasking capabilities. This means the tablet can run more than one app in the foreground, leading to intense CPU and GPU usage and consequently more heat production. For example, a user could be using our video editing app on one half of the screen while browsing the internet or using map navigation on the other half. This scenario would significantly stress the device more and more, and a lot of heat will be generated, meaning that the device will probably reach the thermal throttling limits, making it vital to include such a tablet in our test lab to assess performance under these conditions. Very well. So, in conclusion, option A, a mobile device with a large screen like a foldable phone, is the least important to include in our test lab because its characteristics don't uniquely exacerbate the overheating issues caused by our app. Hence, it's very safe to declare option A as the correct answer to this question.